start there. All right, ratios, new chapter, ratios, rates, and proportions. So ratios are comparing. So we're going to do a bunch of comparing in this chapter, but we're going to be, ratios compare two or more objects with the same units. So the reason why I'm underlining same is we don't have any units that we need to put on our answers. They are just going to have no units. When we get to the next section, which is rates, then that's comparing objects with different units. But we're going to compare, and we have our forms. They have ratio form, right? Which is the one with colons, like if I was going to do A to B, or A to B to C. Okay, that's the majority. If I'm writing a ratio, that's the one that gets used a lot of the time. We have word one, A to B, with the little 2. It's a comparison, A to B. And then we have fraction form. Okay. So this one can be, oh, just let me figure, A to B to C, right? I can have more than one term using this form and this form, but fraction form, I can only write it in that form like that. I cannot do A over B over C, right? That does not work. I cannot use fraction form in ratios if there's more than 2 numbers. And my denominator also has to be a total if I'm going to use fraction form. If it's not one of the totals, and I'll explain that in my example, then I cannot use fraction form. I can only use the other 2 forms. All right, so those are my forms. And hopefully you remember that. We did a bunch of them last year. And I think we even touched it briefly in grade 6. I think, it starts in grade 6 briefly. So 2 terms, right? Before we do that example right there, just one second. Give you a moment to copy that. I'm going to go down and do part to part and part to whole before we do the example in the middle. All right. Are we good there? So this is my example. This is a bunch of rectangles and triangles and ovals and things like that. So if I'm using this idea here, part to part would be like a rectangle to a triangle. All right. I'm just going to use the figures rather than the words. Rectangles to triangles. Let's say ovals to triangles to squares, right? It's a part to another part, one part of it to another part, that sort of thing. Okay? As soon as I have part to a total, that would be like rectangles to all, or all to ovals to triangles to rectangles, right? Part to whole ratios look like that. And they can be, generally we tend to put them at the end. So if I wanted, we generally put the bit larger one at the end, but it really doesn't matter. So this one here, when we write parts to totals, I can use the ratio form. I can use the word form. And I can use the fraction. No, I cannot use the fraction form. That one over here, I can use the ratio form, the word form, and I can use the fraction form as long as it's only two objects and the total is the denominator. Okay? So out of my examples, the only one I could use in fraction form would be this top one. Right? Because it represents rectangles to all. Because remember, a fraction is something, an amount out of a total. Good there? Not yet. Okay. So if I wanted to do something that could be in a few of the parts to parts, two-term ratios, I could do like 3, 2, 2, 4, 6, 8, 9. 3 to 9 would represent rectangles to triangles, right? I could write it in that form. I could write 3 to 9. I cannot write it as a fraction, right? But if I had gone, let's say 9, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 9 to 18, right? I should be able to reduce these also. We'll get to that. But this would represent, I could write it as 9 over 18, and I could write 9 to 18, because this one represents triangles to all. That's like the biggest thing here, is just to remember when you can write a fraction and when you can't write a fraction. Does that make sense to people? Good. 3-term ratio, I could do 3 to 9 to 6. That would represent rectangles to circles to, or rectangles to triangles to ovals. And I could write 3 to 9. Oh. 2, 6. None of that should be a surprise. Okay. I'm going to go to the 1, 2, 3, 4, 5 on the next page, and then come back to the punch example. Let's go to these boxes here. So some of the things that you need to remember with it. So anytime you write a ratio, you need to have lowest terms. All right, you need to have lowest terms. So if it comes out to be 6 to 24, then you need to go to 1 to 4. Make sense? I can reduce each by 6, take a 6 out of 6, and then take a 6 out of 24, and divide. Equivalent ratios. They may ask you for an equivalent ratio. These essentially are equivalent ratios. They mean the exact same thing, right? If I have 3, let's say I have a 3 over 7 in a fraction form, and I want another equivalent ratio. You get the choice of whatever you'd like to do. You can, as long as what you're multiplying the top and the bottom by is the same thing. You like to multiply by 2? Why not? We could do 2. 6 over 14. I could multiply by 6. As long as what I do to the top and the bottom is the same thing. 18 over 42. All of these are equivalent. Okay. As long as you are multiplying the top and the bottom by that same number, right? Oh, I spelled equivalent wrong, didn't I? I don't know if that made it much better. That's okay. How about, are they equivalent? Equivalent. Let's say I had 6 over 9 and 2/3. Are they equal? Okay. Here's the shortcut. If you multiply the diagonals, and those two numbers come out to be exactly the same, they're equivalent. So let's say I had 3 out of 9 and 4 out of 9. No, let's go 4 out of 6. Right? If I do that diagonal, I get 36, and if I do this diagonal, I get 18. Totally different. So not equivalent. This one is a yes. That one would be a no. You can only reduce or go to reduce or put ratios in lowest terms if they are in the same units. Since ratios have to be the same units, we cannot reduce things that do not have the same units. And if they do not have the same units, then they better be writing the units on like this: 3 dimes to 4 quarters. So I get the ratio of 3 dimes for every 4 quarters. You give me 3 dimes, you have to give me 4 quarters. You give me 3 dimes, you have to give me 4 quarters. But they are totally different units. So in order to write a fraction or to write that ratio without those units, I have to make them the same units, right? So can I make dimes become quarters without going, and you don't want decimals. You want to try to stay away from decimals. And you don't want fractions. No. Right? And you want to get it as simple as possible. So would I change 3 dimes into quarters? What it's worth in quarters? Because that would be like what? One quarter and some left over, right? That doesn't work. So we could change it into cents. What is it worth? What is 3 dimes worth?
30 cents.
30 cents, right? Find something that they both work to. 4 quarters is a dollar, so it's 100 cents. 30 to 100. Since each of them have a 0, I can cancel 1 0 on both of them. I'm now down to 3 to 10. Is that the lowest I can go?
Yeah.
Yeah, because 3 is prime, and also I can't, that sort of thing. All right, so figure out. Yeah. Oh, just take the sheet off and just write it on the next sheet. Slide it underneath. I forgot to do a sheet for today. Okay. So what happens if we end up with something that is in 6 to 2 decimal 5? Same units, but we never want to leave our answers with fractions and decimals, right? I'm comparing something that is 6 of one and 2.5 of another. How do I get rid of a decimal? I don't have to go as far as 100, right? 10, because I only have one decimal place. If I want to remove one decimal place, times this one by 10. But what I do to one thing, I have to do to the other. So this side becomes 60, and this side becomes 25. And then I can reduce. Since both of them are divisible by 5, right? How many 5s are in 60? 5 into 60. 1, 12, right. And 25 divided by 5 is 5. And there's my lowest terms. All right. And a lot of times the reason we use fraction form allows us to compare things better. It really allows us to compare things. Let's say that I have 4 over 7. And I have x over 28. When I write it in this form, it's easy to see that what did I have to do to 7 to get it to be 28? I times by 4, right? And therefore, I'd only have to times the top by 4, and I would get x to be 16. When I write it in ratio form, it's harder to see what is being compared because it's linear, right? It's in a line. And it's hard to go with what goes with what, right? Right, I have to kind of draw arrows. This one goes with that one, and this one goes with that one. Firsts go with first, seconds go with seconds. And it's harder to figure which one goes with what, right? So we tend to write things in fraction form so that it's easy to compare because the denominators will go together, the numerators will go together. Whereas this is all one line. So it's harder to decide what will my x be in a straight line, right? So I tend to use fraction form when I'm finding a missing piece. Okay. I think I'm going to leave the fruit punch this punch recipe example alone and just use one of the questions in the assignment for my example on that instead of doing a big question. So I'd like you to flip to 18. Yeah, let's go to 18. Let's go to 18. It's on page 4. Nope. Page 4, number 18. And again, all my numberings are wonky, right? There's 13, 17, 18, 19, 3, 4, 5, and 9. All on the same page. I just kind of randomly place things. If they fit, I put it there. All right? So for like number 18, it says, at the corn roast, 3 cobs are cooked for every 7 people. If there's 114 cobs are cooked, how many people are at the roast? This is the place where I would want to use a fraction to compare. So they always give you one of the ratios, right? They tell you what the comparison is. It's 3 cobs for every 7 people. And the reason I'm going to write it in fraction form is so that I can easily decide where that 144 goes. And I like to, in this form also, I put some units on just so I remembered what is what. So 3 cobs are cooked for every 7 people. If I have 144 cobs, where does the 144 cobs go? Is it in the numerator or in the denominator? Numerator, because the cobs are up on top in this fraction. So 144 is going to go there. My x is going to go on the bottom. So now I have to figure out, what did I multiply 3 by to get 144? Right? Now there are a couple of things where maybe using a calculator might be okay, and this is probably one of them, right? So I would take 144 and I would divide by 3. And you could do it longhand too, right? 3 into 144. That gives me 4. Use up 12. 48 times, right? So I'd have to times by 48 there. Times by 48 there. So 48 times 7 gives me 56. 7 times 4 is 28 plus 5. 28 plus 5 is 33. So the x would be 336 people. That's doing the math, keeping your brain sharp. Or you could have gone 144 divided by 3 in your calculator and got 48 and gone 7 times 48 and got the 336. Try to do it without a calculator. It makes your brain smarter, right? Cross off. No. I want to go do that question. I was going to think of crossing off, but then no. Let's look at this question here. Find the missing term. I have a 12 to m equaling a 7 to 14. Now, I always tend to write these in fraction form because of the fact that it's easier to figure out what goes with which. So I just go numerator over denominator equaling numerator over denominator. Now, the problem is there, if I go this direction, because that's the one that has the unknown in it, is there any way of getting a 7 to become a 12? No. Right? Darn it. How do I do this question then? Sydney? Exactly. So sometimes this fraction, if it doesn't work, you can't make a 7 become a 12, go and reduce it. 7 over 14 becomes 1/2, right? Now can I make 1 become a 12? Yeah, simply divide times by 12. So 2 times 12 gives me 24, being my denominator. Some years people see it, which I'm glad you guys did. And other years I'm like, oh, they were like, no, don't see it. Glad you could see that. Do we remember our metric conversions? Centimeters, meters? Yeah? Well, we'll write them over. Let's go put them back in our notes here, because you're going to have to be able to convert. Let's use that little space that's up here. It's above our punch. I tend to write them like this, and the reason for that is kilometers is our biggest unit, meters is our middle one, millimeters is our smallest one, and then we have centimeters one up from millimeters. If I'm converting from millimeters to centimeters, it's a ratio of 10. 10, this one's 100, and that one's 1,000. So if I'm going this direction, I multiply. If I'm going this direction, I divide. Or I can move my decimal places, however many zeros. So 3 decimal places here, 2 decimal places here, 1 decimal place there. And you're moving them in the direction. So if I'm looking at 50 centimeters and 2 meters, I generally want to take my largest and put it into my smallest, because that will reduce getting decimals, right? If I put centimeters into meters, I divide by 100 and get decimal 5. I don't want a decimal. So I'm going to take meters and change it to centimeters. So meters to centimeters means I move 2 decimal places in that direction, which is to the right. So 2 meters, 2 decimal places gives me 200. And as soon as I have them both in the same units, I can drop my units. Does that make sense? Am I done the question? No, I gotta reduce. Cancel some zeros. I'm now down to 5 to 20. Right. I can reduce both by 5 now. 5 divided by 5 is 1. 20 divided by, right? 20 divided by 5 is 4, and then I'm done. If I went the other direction, I would have gotten decimal, right? But it works the same. If I divided this by 100 to get it to a meter, I would have decimal 5, and I'd have 2. How do I get rid of a decimal again? Times it by 10, that becomes 5. This becomes 20. Then I got 1 to 4. Would I have ended up with the same answer? Yes. It depends whether you like working with extra zeros or whether you like working with decimals. Yeah.
Do we have to write it like we're dividing it by 5 and
No, you don't have to write these in. I'm assuming by grade 8, you can do those mentally. Yeah. I made you do it back in grade 6 because that's when we were reducing things. Okay. Let me just flip through, make sure I've covered all the different possibilities of answers. Make sure you put your units always in lowest terms for everything. So if they make you write a fraction, you need to make sure that it's lowest terms every single time. We did comparing. Oh, they threw in one. I'll go to the sports one. Page 5. There's a couple of them. They ask you to throw in a percentage, fraction, decimal, percent. No, we can do it. Let's do an example. It says use the data about wins and losses in hockey, volleyball, and basketball to answer the following question. Which sports have an equivalent win to loss ratio? Well, you can figure that. One. But let's look at this. What is the ratio of wins to total games played for hockey? Let's do that one here. So we have wins to total games. How many wins do I have for hockey? 9 wins. And I can put it in fraction form because my denominator is going to be a lovely fraction. What are the total number of games that they played? 15, because the wins plus the losses gives me 15. Give your answer as a fraction, a decimal, and a percent. So there's my question. Let's do the fraction first. Well, how would I rate that as a fraction in lowest terms? Reduce it. What is common between 9 and 15? 3? Does everybody see that? 9 divides by 3 to give me 3. 15 divides by 3 to give me 5. There's my fraction. Okay. Keep going. How do I get into a decimal? Yep, top divided by bottom. 3 divided by 5. 3 divided by 5. Top divided by bottom. 0.6. And a fraction. Oh, no, we did a fraction. Percent. What does a percent mean? I need something out of 100. 60%. Or you could just take your decimal, times it by 100. 60. Now, how do I go? If I didn't know that, I could do this. What decimal place is that 6th? The 10th. 6 out of 10 is 60 over 100. That's another way of getting there. Yes? Okay. And I think that covers every possibility out there. I think you got it all. So, yep. All right, that is ratios. And that's the last time I think you see ratios. Yeah, this is the last time I see ratios again within like this scheme of things. They just assume you know everything about ratios after this. So this is the last time we actually sit down and do ratios and just go part to whole and all that. They just assume you know it after this.
You mean like till we graduate, or like just
Like you use them again, but we just don't have a formal lesson on them. We just kind of throw them into questions from now on after this.
like till we're 12, not
Yep.